Based on the desired impulse response, the specification include the passband cutoff frequency omega p, the stop band cutoff frequency omega s, and the passband ripple deviation delta p, and also the stop band ripple deviation delta s. All of these parameters, omega p, omega s, delta p, and delta s, can be found in the previous equation for desired impulse response. So, based on this equation, for frequency between 0 and omega p, the pass band cutoff frequency, so within this range, the magnitude of ideal impulse response is larger than 1 minus delta p and lesser or equal to 1 plus delta p. So the magnitude of ideal impulse response is within this range, larger than 1 minus delta p, lower than 1 plus delta p. For frequency between 0 and omega p. Omega p is the passband cutoff frequency. The next one, for frequency between omega s, the stop band cutoff frequency, here, until pi. Okay, for frequency between this range, larger than omega s, the stop band cutoff frequency, and lower than pi, the magnitude of ideal frequency impulse response is equal or lower than delta s. This one, equal or lower than delta s, where delta s is the stop band ripple deviation delta s. So this one is between this region of frequency, and the value of the magnitude ideal impulse response is within this range, where this one is for this frequency range, larger than omega s, lesser than pi, and the magnitude is here between this range, which is equal or lesser than delta s, the stop band ripple deviation. So between omega p and omega s is the delta omega. So for desired impulse response, the pass band deviation and stop band deviations are often given in decibels unit dB based on this expression. So we calculate the pass band deviation and also stop band deviation using this formula, and the unit are decibel dB. So this one for pass band deviation and this one for stop band deviation. While the cutoff frequency is equal to omega s plus omega p, the stop band cutoff frequency and also the pass band cutoff frequency divide by 2. Otherwise, we can determine in terms of Fc, which is equal to Fs, the stop band frequency, plus Fp, the pass band frequency, divide by 2. And the transition band can be computed using this equation. Delta omega equal to omega s, the cutoff stop band frequency, minus omega p, the pass band cutoff frequency. Or delta f is equal to delta omega divided by 2 pi. Delta omega is equal to fs minus fp divided by 2 pi. So it is also equal to fs minus fp. So note that all frequencies are being normalized by the sampling frequency fs, sampling frequency, or 1 over ts. Ts is the time sampling. Therefore, all frequency must be in terms of pi after the filter specifications have been defined, the next step is to design a filter that meets this specification. So for further reading, you can refer to the monograph based on the subchapter Filter Design Final Impulse Response. With that, thank you very much.